All right, so this video is going to go over Module 2 Homework 1 notes, and we're going to start graphing. So talking just very basic, I want to make sure everyone's starting off on the same playing field. So I just want to start off super basic to make sure we're all on the same page. So starting off by graphing equations, we have this coordinate system. This is what's called a Cartesian plane. That's what this thing is called, a Cartesian plane. In our Cartesian plane, we have over here the x-axis is already labeled for us. The x-axis, that is our horizontal axis that goes left and right. That tells us our x values, how far we're going left and right. And then up here, it's already labeled for us. We have our y-axis, which tells us how far we're going up and down. That's our vertical axis. So these two axes together make up the Cartesian plane. So if you notice, the x-axis and the y-axis split up our Cartesian plane into four separate spaces, or what's called four separate quadrants. So this is quadrant number 1. This over here is quadrant number 2. This down here is quadrant number 3. And this is quadrant number 4. So notice it goes counterclockwise. Oops, sorry, 4. Also, a lot of times this is written in Roman numerals. So we have 1, we have 2, we have 3, and we have 4, which is the IV. So those are our 4 quadrants. In the middle, where these two things meet, is the ordered pair 0, 0. And this is what's called the origin. For our ordered pairs, they are x comma y. And that first number, notice it's in alphabetical order, so x comes before y in the alphabet, x comes before y in our ordered pairs. That first x coordinate tells us how far we're going on our x-axis, left and right. And that y second coordinate, second number, tells us how far we're going up and down from our starting point. So this starting point in the middle is 0, 0. That is what's called our origin. So let's use this example. It says, in what quadrant does -3, 1/2, comma, -1 lie? Let's use a different color. So we're going to go, our x value is -3.5. So we're going to start at 0, 0 and go over 1, 2, 3.5. And then for our y value is -1. So that means we're going to go down 1. So where these two things meet will be our point. Oops, it's a little bit big where you can't really see it's 1/2. So right here will be our ordered pair. So over -3, oops, I just deleted a bunch of stuff, accident. Over 1, 2, 3, I'll get it right one time. 1, 2, 3.5. So over -3, down -1. So somewhere right there. So that point lies in quadrant 3. And then we also have to check our scale. So notice I labeled the -3 and the -1 to show me my scale, to show me that each little tick mark counts as 1. Make sure whenever you're graphing that you also label your scale, because each little tick mark can count as 1, it can count as 10, it can count as 1/2. You can count as whatever you want, so make sure that you always check and label your scale. So next, is this equation linear? If I were to graph this thing, would it come up into a straight line? By the way, quadrant 3, again, you might want to label it using Roman numerals. All right, so is it linear? So by definition, a linear equation in two variables is an equation that can be written as ax plus by equals c, where a, b, and c are just numbers, no fractions, and a and b are both not 0. So ax plus by plus c, ax plus by equals c is our standard form. We will need to know this and we will use it again in the future. But what this is really saying, looking at our standard form, what do you notice? Biggest thing that I notice is that a is to the first power, b is to the first power. There's nothing else happening to those variables. So our rule is that it is linear. The equation is linear. If the degree is the highest exponent. So if the degree of the highest exponent is 1. In other words, nothing else is happening. Nothing else is happening to our variables. All right, so let's do some examples. So for example, is this equation linear? And if not, what does the graph look like? Is it a straight line? If it's not a straight line, what does it look like? So starting off example A, 3x plus y equals 2. Well, that one's pretty easy. When you look at it in its standard form, ax plus by equals c. X is to the first power, y is to the first power, nothing else is happening. So yes, this is going to be a straight line. Yes, this is linear. Example B, going down, y equals the absolute value, those are absolute value bars, minus 2. So this time we have a little issue. This time we have these absolute value bars. So those absolute value bars we didn't talk about in our rule. So that means something else is happening to our variables. So that means no, it's not going to be linear. And what is this? Let me put here, because absolute value bars. So if it's not a line, what is it going to look like? It is going to look like a V, and we'll see one of these examples in a minute, and that's how I knew that. So looking at example C, y equals 1/2 x minus 5. So looking at this, there's a 1/2, there's a fraction, but nothing else is happening. X is to the first power, y is to the first power, nothing else is happening. We've seen back from module 1 that we could get rid of fractions by multiplying by the LCD, so we can multiply everything by 2 and cancel out that fraction. So that means yes, this is linear. This would be a straight line if we were to graph it. And lastly, example D, y equals x squared plus 2. This time we have that squared. So our degree is 2, our highest exponent is 2. So that means no, it is not linear because of the squared. So what would this look like? This would have a U shape, and we'll see that in a second as well, which is called a parabola. And that, I just know that from doing some examples, which we're going to do in a second. So let's go ahead and let's try to graph some of these things. So our first example says create a table of values to graph x cubed plus y equals 6. So it tells us to create a table of values. It tells us how to graph this thing. So it means I can plug in whatever values I want for x. Totally up to you. Make sure that you show all sides of the equation. So you have the negatives, you have the middle with 0, and then you have the positives. But whatever numbers you want. So let's plug in -1, let's plug in 0, let's plug in 1, and let's plug in 2. So we can choose any values for x. And we're going to plug those in, see what y is, plot the points, and connect the dots. So starting off, -1 cubed plus y equals 6. -1 cubed in our calculator, -1 times -1 times -1. By the way, let me show you real quick how that would look in our calculator. so -1 cubed. So in parentheses, we have, oops, helps if I turn it on. In parentheses, right here's my parentheses, negative. So I'm going to use this negative. This is a subtraction symbol, so I'm going to use this as a negative. So -1, closing my parenthesis, to the third power. This is what's called our caret button. That's going to raise it to the third power. Press enter. We get -1. All right, so it's opening back up. Okay, so going back where we were at. Okay, so we know -1 cubed is -1 plus y equals 6. If we were to get y by itself, we can add 1 to both sides. And that way those would cancel. We're left with y equals 6 plus 1, which is 7. So remember, our ordered pairs are x comma y, so that would give me the ordered pair -1 comma 7. All right, so let's do the next one. So plugging in 0. So 0 cubed plus y equals 6. In our calculator, 0 cubed, 0 times 0 times 0 is 0. Plus y equals 6. 0 plus y is just y. So y equals 6. So that will give us the ordered pair 0, comma 6. Plugging in +1. So 1 cubed plus y equals 6. +1 cubed. So 1 times 1 times 1 is 1. Plus y equals 6. Getting y by itself, we can subtract 1 from both sides. So that way those cancels. And we're left with y equals 6 minus 1, which is 5. So that next ordered pair is 1, 5. Last but not least, plugging in +2. So 2 cubed plus y equals 6. In our calculator, 2 cubed, 2 times 2 times 2 will give us 8. Plus y equals 6. Solving for y, we can subtract 8 from both sides. We get y equals 6 minus 8, which is -2. So 2, -2 would be that last point. So now we have 4 points that we can plot on our Cartesian plane, connect the dots, and we're done. So -1, 7 means that my x value is -1. I'm going over to -1. And I'm going up 7. 1, 2, 3, 4, 5, 6, 7. Over -1, up 7. There's our first dot. Next, over 0, up 6. So boom, there's my next dot. Next point, over +1 and up 5. So right there, that's our 5. So that's our next point. And last but not least, over +2. Down -2. Over +2, down -2. There's our last point. So now connecting the dots. Our graph will look something like this. Our graph goes on forever, so make sure that you draw arrows on the end to show that it's going to go on forever. Same thing for the next one. Create a table of values to graph the equation y equals negative absolute value of -2x. So you can plug in whatever you want for x's. Again, I want to plug in easy numbers, -0 and positive. So -1, 0, and +1. So y equals negative absolute value of -2 times -1. So inside our absolute values, order of operations tells us to work inside the absolute values and then out. So -2 times -1. Will be negative absolute value of +2. The absolute value of +2 is just 2. And then don't forget to bring down this negative. So this negative is just staying out front. So our answer is -2. So the absolute value of 2 is just +2. Remember, the absolute value just makes it positive. So it became +2, but that negative is floating outside, so that negative is going to stay out front. So that means our ordered pair here is -1, 2. Next, plugging in 0 for x, y equals negative absolute value of -2 times 0. -2 times 0 is just 0. So y equals the absolute value, y equals negative absolute value of 0. The absolute value of 0 is just 0. That negative's coming down out front. -0 is still 0. So that ordered pair is going to be 0, 0. Last but not least, plugging in +1. So y equals negative absolute value of -2 times +1. Negative absolute value, -2 times +1 is -2. So y equals that negative just staying out front. The absolute value of -2 is +2, and that negative just staying down out front. So that one is also -2. So that ordered pair is 1, -2. So now we have 3 points that we can plot and connect the dots. So first, -1, 2. So over -1 on our x-axis. Oh, this is supposed to be -2. -1, -2. So over -1 on our x-axis, and now down -2 on our y-axis. So right there is our first point. And then our origin, 0, 0, over 0, up 0 is our next point. And then over +1, down -2 again is our last point. So connecting the dots. There's our graph. Because of the absolute value bars, that's what gave us that V shape, and that's how I knew, going back up here, that the absolute value bars were going to be the V. So that's that example. And that is all of Module 2 Homework 1 notes. If you have any questions, as always, please email me or our class peer tutor. Good luck.